right, this is going on page 106 when we are done. We're kind of putting everything together. We have our identities that we're going to have to use, and we're solving equations. We have solved equations. We did that before we started the identities. And now we're going to have to fix some things before we just factor or use our basic algebra and whatnot. So if you look at number 1, where we have cosine of x minus 1 equals sine squared of x. We have an equal sign, so it's an equation. We want to solve it. It gives us an interval to solve it on. But when we have a quadratic, usually that means we're probably going to have to factor it, but I can't mix my sine and cosine. Now, there are times where you can mix the trig functions, but this is not one of them. And we'll talk about what those are once we get there. But I can either change it all to sine or all to cosine. And if I can change anything, the easiest thing to change would be the squared ones, because I would have something on my Pythagorean identities that I could use. So looking at your Pythagorean identities, what could I substitute for sine squared? 1 minus cosine squared. Very good. So we'll have cosine of x minus 1 equals 1 minus cosine squared x. Okay. And then we have a quadratic, so we want to set it equal to 0 before we factor. Whether or not it's a quadratic, if you're going to factor in any way, you have to set it equal to 0. Some of you are still trying to factor things when it's not even set equal to 0, and nobody in the entire universe has ever shown you to do that, so don't do that. I don't know where that's coming from. But just like if this was plain old x squared and not cosine squared, we would want that term to be positive, which tells me I want to move everything over to the left. So that will give me cosine squared x plus cosine x. And then I have a negative 1. I'll subtract another one, so that's minus 2 equals 0. Then we have a very simple quadratic to factor. Of course, if you never bothered to really get factoring when it was plain old x's, when it has trig in it, you're going to really struggle with it. And that's not something I can even help you with anymore at this point, because we've done it a bazillion times. So we're going to factor. It's going to give me cosine x and cosine x. And then since that's a negative 2, and this is a positive 1, that would give me like plus 2 and minus 1. And I have a factor. All right, so now that it's factored, I can use my zero product property and solve this. This one would give me cosine x equals negative 2. This one would give me cosine x equals 1. Right. Then we look at what part of the unit circle we're using here. So we are going from 0 to 2 pi. That's the entire thing. Right? So from 0 to 2 pi, what angle gives me a cosine value of negative 2? None, right? So x is equal to the empty set here. There's nothing. From 0 to 2 pi, when is cosine 1? 0 and 2 pi. Good. Which means in the end, my answer is 0 and 2 pi. So that interval that you're given, that 0 to 2 pi, sometimes that can be written like this. If so, your only answer would be 0 in this case, but since they both have brackets, that's why it's 0 and 2 pi. Okay? We're good on that? All right, so let's look at number 2. So I have a cotangent squared and a cosecant. So this is very similar to this first one. I don't want to mix those in this way, so I can look at my chart, and what can I substitute cotangent squared for? Cosecant squared minus 1. Good. So cosecant squared theta minus 1 minus 3 cosecant theta plus 3 equals 0. Okay, everybody good? So now this gives me cosecant squared theta minus 3 cosecant theta plus 2 equals 0. Then I have another quadratic that's very simple to factor, so go ahead and factor it. And if you have to wait for me to factor it to get something written down, that is not good. Now, if you have yours flipped around, like if you have -2 and then -1, that's totally fine. It doesn't matter either way, but that's what we should get. And then we're going to use our zero product property here. Cosecant theta equals 1, and cosecant theta equals 2. All right, so what is cosecant the reciprocal of? Sine. So I really have sine theta equals 1, and sine theta equals 1/2. Here, we're going again from 0 to 2 pi. All right, well, when sine is 1, that's a quadrantal, right? So when is sine 1? At pi halves, right there, right? Okay, pi halves. All right, and then sine is positive here and here, right? So I always like to mark it so I make sure I use the right thing. In the first quadrant, when is sine 1/2? Pi 6. And then I also need my second quadrant pi 6th angle, which is 5 pi 6. Very good. All right, so then my final answer here is pi 6ths, pi halves, and 5 pi 6ths. Okay. What questions you got? We good so far? Okay. So on number 3 is not a quadratic, so we're not going to work it that way, but I need to do something here because I have a tangent and a sine, and again, I'll explain to you when we can mix them and when we can't, but this is another time where we can't. But I do know that I can change tangent into something with a sine in it, right? We agree with that? So I can make this into 3 sine alpha over cosine alpha minus 2 square roots of 3 times sine alpha equals 0. Now, I'm mixing sine and cosine here, but that's okay because I have 2 terms, and in those 2 terms I have a GCF. Can I factor out a GCF? What is my GCF? Sine, right? So I can factor out the sine alpha. So sine alpha times 3 over cosine alpha minus 2 square roots of 3 equals 0. Okay. So now I still have them mixed, but if I use my zero product property, it's not going to matter. It's not like I have them in one thing. But I think before I do that, I would rather cosine not be in the denominator. Like I could leave cosine there and take care of it that way, but it's really better if it's not. So I'm going to rewrite this as sine alpha. I wouldn't say it's better. I think, in my opinion, it's easier to work with. So what's the reciprocal of cosine? Secant. So I can really make this into 3 secant alpha minus 2 square roots of 3, and then set that equal to 0. That way I don't have one of the variable ones in the denominator. Okay, so now that I have that, I can do my zero product property here. And I have sine alpha equal to 0. Here I have 3 secant alpha equal to 2 square roots of 3. Right. So that means here I would have secant alpha equals to 2 square roots of 3 over 3. So the reciprocal of secant is cosine. And what's the reciprocal of 2 square roots of 3 over 3? Square root of 3 over 2. Good. So on this one, I am going from pi to 2 pi. Well, when sine is 0, that is a quadrantal. So from pi to 2 pi, when is sine 0? Pi and 2 pi. You don't have to whisper it, it's okay. And then in these 2 quadrants here, cosine is positive here. what is the reference angle, like my first quadrant angle, what's the reference angle that gives me a cosine value of the square root of 3 over 2? Pi 6. So my fourth quadrant pi 6 angle is 11 pi 6. So in the end, alpha is equal to pi 11 pi 6 and 2 pi. So not only is not ever really understanding factoring going to be a problem, if you never really bothered to learn your unit circle angles, then good luck. I don't know. Okay. It's not like I haven't told you a million times. All right, what questions we got? Anything? All right, so let's look at number 4. Now, the first thing I write down in number 4, I do not want you to write down. Okay, so put your pencils down, don't write this down. If we start this the same way that we started number 3, it would look like this. 1 over cosine x minus sine x over cosine x equals 1. Okay? Now, I have on the left-hand side, I do have a GCF of 1 over cosine x that I could factor out. The problem is we can't start factoring until we have set it equal to 0, right? So if I actually set this equal to 0 and I move that 1 over there, am I going to have a GCF anymore? I'm not, right? So I can't work this. So this one doesn't work out exactly like that one does. I can't force it down that road. So we have to go down a different road. All right, so I'm going to erase this. I just didn't want you to waste your space on that. And then we have to think of another thing to do. Well, secant and tangent are related to each other in the Pythagorean identities, right? These are not squared, so it's not a direct relation like that, but we can sort of force it down that road. So in order to do that, I'm going to move my tangent over. So this gives me secant x equals tangent x plus 1. Okay. Now, if those were squared, things would turn out nicely. So we are going to square them. Okay, so we will square both sides. And then we're going to put a big old star over here because when we do that, there's something additional that we have to do at the end that we're going to come back and talk about. Okay? So this gives me secant squared x equals, if that right-hand side is not tangent squared plus 1 because it's tangent x plus 1 times tangent x plus 1. That gives you tangent squared x plus 2 tangent x plus 1. If you need to write out tangent x plus 1 times tangent x plus 1 and FOIL it to get that, that's fine. I'm going to kind of skip that process, but you got to be able to multiply that out correctly. Now that I have that secant squared, well, I have secant squared and I have tangent squared. Which one do you think would be better to replace? Like I could replace this with something that has secant in it, or I could replace this with something that has tangent in it. It would be better to replace this one, right? Since we have this other tangent over here. Makes sense? That's kind of how you make that decision. All right, so when you look at your chart, what can I replace the secant squared with? Plus 1. Okay, so tangent squared x plus 1 equals tangent squared x plus 2 tangent x plus 1. Okay. So now I have it all in terms of tangent. I have a quadratic, so I want to set it equal to 0. So when I subtract tangent squared from both sides, those 0 out, right? That's nice. It's no longer a quadratic. When I subtract 1 from both sides, those both 0 out. So I'm left with 0 equals 2 tangent x. So then I can divide both sides by 2, and that gives me that tangent x is equal to 0. I'm going from 0 to 2 pi, the whole thing. So when is tangent 0? 0, pi, and 2 pi. So 0, pi, and 2 pi. But I am not ready to box my answer because here's why we put that star up there. When we are solving equations, if we take the square root of both sides, we know we have to put a plus or minus, right? If in the process of solving an equation, we square both sides, then we may have an extraneous solution. Because let's say that all of our solutions are actually negative. If I have squared things along the way, that introduces the positive solution as well. Does that make sense to you? And so it's possible that all three of these answers are good. It's possible that all three of them are bad, or it's possible that some are good and some are bad. So we have to check them. You don't have to check your answers on every single one of them. You have to check them when you have squared both sides as a process to solve the equation, okay? So we're going to take this 0, and we're going to substitute it back into the original one. All right, so what is secant the reciprocal of? Cosine. So what is the cosine of 0? 1, okay? And the reciprocal of 1 is 1, so I'm going to write down 1. So secant of 0 is 1 minus, what's the tangent of 0? 0, right? And then equals 1. Well, that works, right? That works, so we like that one. So then I'm going to substitute in pi. What's the cosine of pi? -1, and then the reciprocal is -1. So the secant of pi is -1. Minus the tangent of pi is 0. That does not equal 1, which means that the pi is not actually one of our solutions. Now, because I think my knuckle did that, ignore that part. But so -1 minus 0 is not 1, so that doesn't work. Well, 2 pi is in the same place as 0, so if 0 worked, is 2 pi going to work? Yeah, the answer is yes, because they're really the exact same angle. That's okay. But you see what I'm saying? Like, we don't have to really go through the process of that because it's literally the exact same angle. And so my actual answer in the end then is 0 and 2 pi. And that's all I've got. Okay? So if you introduce squaring both sides as a process to solve it, then we have to check for extraneous solutions. Okay? What questions we got? Okay. All right, so now on the notes, the little things off to the side here kind of give away what we're doing, which is fine, but you know, that means you don't have to necessarily think as hard, which you will have to on the others. But I have a double angle in here. If I have a double angle, I want to replace that double angle. So sine of 2u, what does that become? Good. 2 sine u cosine u. Okay, so I have replaced that sine of 2u. Then I'm going to rewrite the rest. Plus 4 cosine u equals 3 cosine u. So this is one of the situations where I have sine and cosine mixed, but the fact that they're multiplied together and they're not in separate terms, that's not necessarily that bad, because maybe I can factor out a GCF, but not yet, because it's not set equal to 0. So I'm going to move that 3 over, the 3 cosine u rather, so I get 2 sine u cosine u, and then when I subtract 3 cosine u from both sides, that'll just give me plus cosine u equals 0. Okay, we all good with that? So now, do I have a GCF? Yes. So I can factor out my GCF. I have cosine u. I'll multiply that by 2 sine u plus 1 equals 0. So even though they were mixed, now when I have my zero product property, they're no longer mixed, and that's okay. All right, so here I have cosine u equals 0, and I have 2 sine u equals -1, which means sine u equals -1/2. In this case, I'm going from 0 to 2 pi. That's the whole circle. So when is cosine 0? And 3 pi halves. Very good. So u is at pi halves and 3 pi halves. Right? And then sine is negative in the third and fourth quadrants. what angle, what reference angle gives you a sine value of 1/2? Pi 6. Okay, so I need my third quadrant pi 6 angle, which is 7 pi 6, and my fourth, which is 11 pi 6. So all together, I get that u is equal to, let's see, we're starting at pi halves, then we have 7 pi 6, then we have 3 pi halves, and then we have 11 pi 6. Do I need to check these answers? No, because we didn't square both sides, so we're good. What questions you got? All right, so let's look at number 6. Number 6, we have a cotangent of 2 theta. So look at your double angles. Do you have a cotangent of a double angle? You don't, right? We have sine, cosine, and tangent. But what's the reciprocal of tangent? Cotangent. So cotangent is the reciprocal of, so we just, exactly. You just flip the whole thing over. So when I replace cotangent 2 theta, I look at that tangent 2 theta and just write it upside down. So this is 1 minus tangent squared theta over 2 tangent theta. Make sense? Just flip the whole thing. And it's okay to do because it's all one fraction. It's not like I'm flipping multiple fractions there. So then that's times 2 tangent theta plus 2 equals 0. Right, because I still had to write the rest of it. Can I reduce anything here? Yep, I can cancel those out. So that leaves me with 1 minus tangent squared theta plus 2 equals 0. So I have a quadratic. First thing I want to do is, well, it is set equal to 0, but I'd like that tangent squared to be positive. So I'm going to move everything over to the right, and I'm going to get tangent squared theta, and then 1 plus 2 is 3, so it'll be minus 3. So it is a quadratic. Just because it's a quadratic doesn't mean that I can factor it. This looks like it could be a difference of squares, but it's not, right? So I'm not going to force it down that road. Instead, this is a time where now I just have to move that 3 back over. 3 equals tangent squared theta. And one of the reasons it's best to see if you have a difference of squares first before you do this is because a lot of you, way too many of you, continually forget to do what when you take the square root? Put a plus or minus. Y'all know what a cuss jar is? You ever had one of those at your house? Like if somebody at your house cusses, they have to put like $1 in the jar or whatever. Okay, so I've thought about I need a plus or minus jar, and I'm going to start charging you money. And maybe the threat of financial ruin in your life because you forget plus or minus, maybe that'll help you remember it, but you cannot forget plus or minus. So when we take the square root of both sides, this is the tangent theta is equal to plus or minus the square root of 3. Any of you make a lot of money off your parents when you had a cuss jar? I don't know. We never had one. My dad, he definitely would have been in financial ruin, I think. So we're going from pi halves to 3 pi halves right here. And this is plus or minus, so I need both of those. What is your reference angle that gives you a tangent value of the square root of 3? Pi thirds. Good. So then your second quadrant pi thirds angle is 2 pi thirds, and your third quadrant is 4 pi thirds. There we go. Okay. What questions you got? Anything? We good? Okay. So now we have sum and difference. Now when you look at what we have here, this sine of pi 6 minus beta and cosine of pi thirds minus beta, those also look very similar to your cofunction identities. But notice on the cofunctions, all of them are pi halves minus theta. Like pi halves is your only option when you use that cofunction identity. So instead, the way we look at these is we look at this as sine of a minus b, and this is cosine of a minus b. A being pi 6th here, b being beta. Okay, you see how that works there? So we're going to start with this first part, this sine of pi 6 minus beta. And we're going to look at this, and we're going to find sine of a minus b. Okay, you find it in the difference of angles identities. So we're going to substitute. When you do that, you get the sine of a, which is pi 6, times the cosine of b, which is beta, minus the cosine of a, which is pi 6, times the sine of beta. Okay? Everybody with me? That all just comes from the sine of a minus b. That's it. So then I have to do this part. Minus, and this is going to be more than one term, so I need parentheses. Now the cosine of a minus b gives you cosine of a, so the cosine of pi thirds times the cosine of beta. Is it plus or minus? Plus the sine of pi thirds times the sine of beta. And that all equals the square root of 6 over 2. Okay? Everybody good so far? Any questions about where anything came from? All right. So now that was a lot of stuff to write out, so you got to make sure that you don't lose yourself in all of that and make sure you understand where I got it from. But now we can simplify this sum. Like some of this we can actually calculate. Like what is the sine of pi 6? 1/2. So this first part here is going to become 1/2 times the cosine of beta. Minus, what's the cosine of pi 6? Square root of 3 over 2. So this minus the square root of 3 over 2 times the sine of beta. Minus, then I got to do this part. What's the cosine of pi thirds? 1/2. This is 1/2 times the cosine of beta. And then I have to distribute this negative here, so this is another minus. In this part, what's the sine of pi thirds? Square root of 3 over 2 times the sine of beta. And all that equals the square root of 6 over 2. So we've cleaned it up a little bit, right? Clean it up a little bit more. I have 1/2 cosine beta minus 1/2 cosine beta. Those zero out. Then I have negative square root of 3 over 2 minus the square root of 3 over 2. So we're going to pause and think about this a little bit differently here. If I have negative x minus x, what does that give me? Negative 2x, right? That's a no-brainer. We totally get that, yes? So if I have negative square root of 3 over 2 minus the square root of 3 over 2, doesn't that give me negative 2 square root of 3 over 2? Right? Same thing. And then what happens with the 2's? They cancel out, and you really just get negative square root of 3. Okay? So when you have something that looks like this, which your brain is going to tell you looks difficult and weird, think about what's really happening. Like take it a step back and simplify it a little bit so that you can make sense of it and not make up math or make it harder just for the sake of making it harder. Okay, we good on that? So that means when I combine these two, I get just the negative square root of 3 times the sine of beta equals the square root of 6 over 2. Okay, so now I have to divide both sides by that negative square root of 3. I could make it into a fraction and a fraction, but isn't dividing by the negative square root of 3 over, or I'm sorry, just the negative square root of 3, the same as multiplying by 1 over the negative square root of 3? Like, I think that's a little bit better way to write it. So sine of beta is equal to the square root of 6 over 2 times negative 1 over the square root of 3. Now, when we do this, this becomes negative square root of 6 over 2 square roots of 3. When you have square roots in fractions, and there's no plus or minus or anything anywhere, you can reduce everything that's inside the square root together and everything that's outside the square root together. So I can make this into that, which means that the sine of beta is equal to negative square root of 2 over 2. Okay, got to understand how your square roots work also. And then this, we're going from 0 to 2 pi. And sign is negative in these two quadrants. What's your reference angle that gives you? Pi fourths. Okay, good. So then I need my third quadrant pi fourths angle, which is 5 pi fourths and 7 pi fourths. Very good. All right. What questions do you have? Anything? We good? Okay. So the next part is half angle identities, but I've already told you we're not going to do anything with those. Even though we hadn't talked about them, we could substitute and do stuff, but we're not going to do that. I don't think it's necessary. Okay. Any questions at all? All righty.